Okay, we're going to continue to look at absolute value, but with inequalities, and we're going to look at solving compound inequality statements. Well, if we're looking at something like negative 2 is less than or equal to y is less than 4, you could write that as two separate inequalities. We know y has to be less than 4, but it also has to be greater than negative 2 at the same time, so we put an and statement in here. Well, how do you graph something like y is greater than negative 2? Well, y is greater than or equal to negative 2. You would put a closed circle, filled in circle at negative 2. You're looking for y is greater than that, so you would shade to the right. Here you're looking for y is less than negative or less than positive 4. So at positive 4 you'd put an open circle, meaning it's not filled in. You're looking for less than, so then you would shade to the left. Well, how does this graph then look? Well, an and statement is where both of these have lines that are filled in. In this case, it is in between. Now, another way to look at it, since y is in between these two numbers here, all you want to do is you want to go ahead and shade in between those two numbers. So if you shade in between these two numbers of a negative 2 and a 4, you end up getting where it works. Now, at negative 2, it's filled in because of the equal to right here. And at 4, it's open because there's no underline for the equal to. So an and is where they are both working or both have information going on the number line. So let's take a look at an or statement. An or statement, we need to go ahead and take a look at this. Y is greater than 3. So you want to go to 3. There's no equal to, so it's not a filled in circle, it's an open one. Greater than means you're going to shade to the numbers that are bigger. Here you have y is less than negative 2. So we're going to go to negative 2. It's going to be filled in because it's a less than or equal to. Less than means you're going to shade to the left. So an or statement is where one of them is shaded, like in here, or where the other one is shaded, like here. Most or statements end up looking like this. They're not all like this, but most of them end up looking like this. So an or statement is where one is shaded, or the other is shaded, or where they are both shaded. That's what an or statement looks like. So let's go ahead and solve this one here. For the most part, you want to go ahead and solve this just by getting y by itself. So here, if you didn't have the left side and you just had the 3y minus 2 less than or equal to 19, you would go ahead and add 2. So we're really going to add 2 to all three parts. Add 2 to your 10, add 2 to the middle, add 2 to the right side. Now we got to get rid of the 3, so we're going to divide by a 3, but we're going to do that to all three parts. So we're going to have an open circle at our 4, a closed circle at our 7. Since our y is in between these two numbers, we're going to have to shade in between. So graphically, your number line would look like this. Well, go ahead and do this one here quickly. So once again, we're going to go ahead and just a second here. Sorry about that. So we'll go ahead and we'll subtract a 5 from all three parts. Okay, we're having issues here. Just a sec. There we have it. Sorry about that. We subtract 5 from all the parts. Now we need to go ahead and get rid of the 2 by dividing everything by 2. So then we need to look at all the numbers between a 3 and a 6. At 3, we need to have a closed circle. At 6, we need to have an open circle because there's no equal to. We're looking at x being between those two, so you want to go ahead and shade in between those two. Here we have an OR statement, so we want to go ahead and continue to get x by itself. So we'd have to go ahead and subtract a 3 from both sides here, and so then we get x to be less than -1. Here, we want to go ahead and get rid of the negative in front of our x. To do that, we'd need to divide by a -1 or multiply by a -1, and we would get this. Remember, when you multiply or divide by a negative, you got to switch your inequality sign. So we know at -1, we're going to have an open circle. At 4, we need to have a filled-in circle. Here we're looking for what's greater than or equal to 4. Greater than 4 would be shading to the right. Here you're looking for what's less than a -1, so that's shading to the left of -1, and there's nothing going to be in between. And an OR statement is where one works or the other works or where they both work. Well, there's no regions where they both work, so this is just our statement. So we want to go ahead and continue to do this one here. Subtract 5 from both sides, divide by -2, filled in at a 3, open at a -4, you're shading to the left of -4. Here you're shading to the right of a 3 because you're looking for greater than, and there's nothing in between. So what does absolute value? Well, absolute value means distance from 0 on a number line. So here you're looking for all the numbers that are less than 4 units away or within 4 units. So in other words, you could be up to 4 units to the right or up to 4 units to the left. What does this one here mean? Well, you're looking at absolute value, all the numbers more than 4 units away. So that means all the numbers below 4 units to the left of 0 or more than 4 units to the right of 0. So if it's an absolute value followed by less than, you can write it as one compound inequality where you have basically your original statement right here, the same inequality sign and the opposite of what you had over here on the right. If it's absolute value followed by greater than, it has to be written as two totally separate inequalities. Now, the second one here is really just the same as this right here, just without your absolute value. I prefer to rewrite this one here, not as this, but as the opposite of our absolute value, what was on the inside. And when you solve this here, yes, you do get this. But I normally write it as these two statements first. And when it's absolute value followed by a greater than, it's always an OR statement. So let's go ahead then and solve this one here. Once again, it's an absolute value followed by less than, so you write it as one compound inequality, because if what was inside was positive, it does nothing. Since it's followed by a less than, you put another less than here, and then you put the opposite of what you had there. Now it's just like solving them like we did before. So add 2, divide by 2, and then you graph it, and since it's in between, you know you're going to shade in between. Here you have absolute value followed by greater than. So you have to write it as two separate inequalities. The first one is just like what it is without your absolute value. The second one is you take the opposite of what was in the absolute value, still greater than your 9. Now you just solve each one. So you're going to have to subtract a 1, divide by 3. Here you're going to distribute through your -1. Now you're going to have to add your 1, divide by your -3. Remember to switch your inequality sign. So you're going to have your two numbers on your number line. And in this case, they're both open because there's no equal to. You want to shade to the left of the -10/3 because it's less than. Shade to the right of your 8/3 because it's a greater than. And there's no shading in between.